Hello, welcome to today's training installment. Today we're going to talk about basic combustion and combustion analysis, along with some post-FER furnace enhancements and updates. My name is Adam Tornator, and I will be instructing today's virtual training. I'm a technical service advisor and instructor at Car Supply. First thing we're going to talk about is the definition of combustion. The definition of combustion is the oxidation of hydrocarbons by burning to produce carbon dioxide and or water vapor. All right, so in a nutshell for today's training, let's refer to combustion as the chemical reaction of converting fuel, whether it be natural gas, propane, what have you, could be even fuel oil, and oxygen into carbon dioxide and or water vapor to release heat energy. But first, let's talk about combustion analyzers. Taking measurements on installation and during startup procedures creates a comparative baseline for operation of the equipment. Okay, so you'll be able to use this information against future measurements to check for any kind of trends or possible, emerging service issues. All right, it's also going to verify the safe operation of the unit or appliance. And you may also have to make some gas pressure adjustments, based on the CO2, carbon dioxide, or oxygen measurements, because not all gas from the gas supplier is the same. Some BTU contents are more than others, so that could fall in line and come into play when taking your measurements. And on top of that, a lot of localities are now requiring combustion analysis to meet certain criteria to be good to go. The next thing to point out on combustion analyzers is to always follow the analyzer's manufacturing instructions. Every analyzer is different from manufacturer to manufacturer. They use different types of sensors. Their maintenance schedules are different based on those types of sensors that they use. So, always make sure to refer to those manufacturer's instructions to make sure you're using the equipment properly and maintaining properly. Now, your typical gas furnace or fossil fuel burning type furnace, you have to achieve or reach what we call a steady state for proper combustion analyzer. This being said, typically have to run a furnace for 10 to 15 minutes per se to achieve that steady state condition. Okay, so when preparing your analyzer, all right, you want to connect the flue gas sampling probes to, the location recommended by the manufacturer instructions. Now, you also want to make sure there's, water. The water trap is clean and dry. All right, and you also want to make sure that you calibrate the meter outside in fresh air and allow it to completely zero before using. At this point, you're ready to perform your combustion test. Once you perform your combustion test, you want to shut the meter off between tests. And if you have to make any, configurations to the furnace or make any adjustments, you want to do so, perform the new test, and then print out your combustion ticket. Okay, this is your typical combustion ticket. Some things to note on the ticket are going to be the fuel type, oxygen. Okay, oxygen is typically referenced as a percentage. Carbon dioxide, which is also registered as a percentage. You're going to have your carbon monoxide in parts per million, excess air, and then carbon monoxide air free. And we'll talk about each of these individually as we progress through the training. Okay. We're also going to be able to break down the numbers and allow you in the field to determine whether or not this piece of equipment is functioning properly and is functioning to the manufacturer's specifications. Okay, it's very common for us TSAs to receive a copy of a combustion ticket from a technician in the field asking us if they're in the green, or if they're in the okay and the furnace is operating to specs. But when we get done with this training today, you should be able to look at these numbers and be able to tell that information yourself before leaving your service call or installation. Okay, so the first thing we're going to talk about on the ticket is your oxygen and carbon dioxide. All right, these again are both reported as a percentage of dry flue gas and are directly related to one another and are affected by the excess air levels, admitted to the furnace or appliance. All right, most handheld analyzers measure the O2 level, and they use calculations to calculate the CO2 level or carbon dioxide level, steady state efficiency, and excess air. Now this chart that we have here is going to show the direct relationship of carbon dioxide to oxygen. And as you can see, as the percentage of CO2 or carbon dioxide percentage increases, the oxygen percentage decreases, and vice versa. Now this is just a standard chart. Obviously these values go a lot higher than what is represented here on this chart. Okay, but like we said, as the oxygen increases, the CO2 decreases. But why does this happen? And what's going to happen when this happens? Unfortunately, it leads us to a place that we probably don't want to go to unless you were a science whiz in high school. Um, you have to go to chemistry class. All right, because it's chemical compounds and breakdowns of molecules that we're going to be getting into here to explain why all this takes place. So what we're seeing here is the amount of force it takes to break these molecules apart. All right, so H2 is a hydrogen molecule that has a single bond of which takes 436 kilojoules per molecule to break apart. Oxygen, on the other hand, has a double bond. It takes 499 kilojoules per molecule to break it apart. And nitrogen has a triple bond, so it's a much stronger molecule that requires 941 kilojoules per molecule of force to break it apart. Now we bring this into the equation because air is made up of 4 parts of nitrogen to 1 part of oxygen. So that, as well as to show you that hydrogen and oxygen are much easier to separate and are more readily to combine with other molecules to create other compounds. So before we jump into the makeup of air and combustion gases, let's just kind of use this little guide here to show what each color is going to represent in these upcoming slides. White is going to indicate hydrogen molecules, black will indicate carbon, orange will indicate nitrogen, and blue will indicate oxygen in our upcoming slides. Now let's talk about a rule of thumb that all of us or most of us have probably heard at some point in our careers in the HVAC field. All right. Typically we are looking for 10 cubic feet of air to burn 1 cubic foot of natural gas. Okay, but what happens if, for instance, less oxygen is available or less oxygen is supplied than needed? What can we expect to happen to that appliance or to happen to that combustion in that appliance? So before, when I referenced air, um, typically air is made up of two parts, or I'm sorry, 3 parts of nitrogen and 1 part oxygen. Okay. Um, but when we reference it as far as combustion goes, we do it in 5 cubic foot increments. Okay. So this is where, when I spoke before, I was talking about 4 parts of nitrogen to 1 part of oxygen. That's going to equal 5 cubic feet of air. Okay. So in this slide, you can see that makeup of that compound. Okay. So again, we want to kind of remind everybody of, the definition of combustion, which is, in our case, is converting fuel, whether it be methane or propane, fuel oil, and oxygen, into carbon dioxide and water or water vapor in the combustion process. So this here shows the compound makeup of 5 cubic feet of air. Okay, because we do it in 5 cubic foot increments. The next thing on our combustion ticket that we're going to talk about is going to be carbon monoxide. All right, this is typically listed in a parts per million basis. All right, it's a colorless, odorless, tasteless, highly toxic gas, often referred to as the silent killer in homes, vehicles, what have you. But carbon monoxide is a result of incomplete combustion. Okay, and then just kind of give you an idea of how carbon monoxide affects the human body. The iron in hemoglobin binds with the oxygen molecules and transports it throughout the body. All right, this binding affinity of hemoglobin for carbon monoxide is about 200 times as great as it is for oxygen. All right, carbon monoxide binding to hemoglobin blocks oxygen transport through a person's body. Okay, and this is why carbon monoxide is so very dangerous when it encounters a person or a human being or any kind of being, living being for that matter. So being that we're talking about carbon monoxide, it's only natural that we talk about the effects and the levels of carbon monoxide and how it affects a living being. All right. So quickly we'll go through this chart here and we'll talk about the different levels of carbon monoxide and what you can expect to experience based on those levels. All right. So 0 parts per million would be, normal fresh air. This is, outdoor air, being around with no like motor vehicles running or anything like that. That would be normal fresh air. All right, at 9 parts per million, this is the maximum recommended concentration for indoor living. Okay, and this is based on an ASHRAE rule. All right, at 15 parts per million is the first level associated with impaired performance. All right, so at 15 parts per million, this is the level that you could first start experiencing some sort of impairment in the human body. Okay, 35 parts per million is the maximum allowable concentration for continuous exposure in any 8-hour period. Okay, so at 35 parts per million, you could be exposed to that for 8 hours a day and be okay. Like, it's not going to have a harmful effect on the body. All right, so 200 parts per million is the maximum allowable exposure level for a workplace. At 400 parts per million, you could start to experience a headache within 1 to 2 hours and becomes life-threatening after about 3 hours of exposure. At 800 parts per million, you can start to experience nausea, dizziness, and convulsions within 45 minutes, unconsciousness, and death within a 2-hour period of exposure. 3,200 parts per million, you could experience those same symptoms, however, now within a 5 to 10 minute period, and unconsciousness and death within a period of 30 minutes of exposure. So this kind of breaks the whole process of the concentration of carbon monoxide and the effects it'll have on the normal body down for you to be able to use in the field. Now, again, 9 parts per million is pretty much the standard that we've all come to realize is kind of the maximum allowable limit for a living space. All right, and it's what we've been using for years. Anything outside of that 9 parts per million creates a hazardous living space and would require the unit to be shut down until a remedy is found or the problem is fixed. So after talking about carbon monoxide and its effects on the human body, what are some of the causes of incomplete combustion? All right, these causes are lack of oxygen, limited combustion air, incomplete mixing of air and fuel, and I'll stop right there because I want to pause and discuss LP kits. Okay, most LP kits come with a spoiler screw that are to be installed in a burner. Okay, and if these spoiler screws are not installed in these burners, it eliminates the proper mixing of the air and fuel passing through the burner. Okay, so I just want to point this out to make sure that everybody is using those spoiler screws in the burners like they're supposed to be. Okay, otherwise it can create problems with combustion in the furnace. All right, and then the next thing, cooling of the flame, flame impingement, high excess air levels. All right, that cools the combustion process. So a good reference point here would be a cracked heat exchanger. All right, a cracked heat exchanger will allow excess air to enter the combustion chamber through the heat exchanger from the blower. All right, therefore impinging the air-fuel mixture of the flame, which will also create an incomplete combustion atmosphere. Okay. Okay, so now we're going to talk about the stoichiometric combustion. Okay, and what this is a theoretical point where the amount of air entering the combustion process provides the exact amount of oxygen needed for complete combustion of gases. Okay, with that being said, this references back to that rule of thumb that we talked about. 10 cubic feet of air for every cubic foot of gas. Okay, so the makeup of this stoichiometric combustion would be 8 cubic feet of nitrogen per 2 cubic feet of oxygen, okay, to make up that 10 cubic feet of air. So with that being said, as we look at our CO2 to O2 or carbon dioxide to oxygen relationship chart, the stoichiometric combustion point can allow for excess levels of CO2 and no oxygen. So we don't use this. We don't use the stoichiometric combustion point as a reference to a proper combustion analysis. Okay, I want to point out on this chart now we have the addition of excess air to the chart. Okay, and the excess air is referenced in percentage points. So like I said in the last slide, in respect for safe and reliable operation of the equipment, we don't strive for that stoichiometric combustion. We strive for complete combustion in which all the hydrogen and carbon in the fuel are converted to H2O, water vapor, and carbon dioxide. Okay, so to achieve this, we have to add more air, or add in more excess air, what we refer to as excess air, okay, than what is typically needed. And again, that was referenced as the black points on the lines in the chart. And again, we're going to go back in reference to our rule of thumb that we talked about earlier. For the 10 cubic feet of air to 1 cubic foot of gas for complete combustion. In fact, with the introduction of excess air, we actually need 15 cubic feet of air to 1 cubic foot of gas. So that rule of thumb really kind of goes by the wayside with the introduction of excess air. And now we'll talk about the compound makeup of the excess air combustion air. All right, so now we're talking about 15 cubic feet of air for every cubic foot of gas that goes into the appliance. All right, so the chemical or gas composition of that air is broken down as follows. You have 1 cubic foot of oxygen, 12 cubic foot of nitrogen, plus 1 cubic foot of carbon dioxide, and 2 cubic feet of water vapor. So this ultimately makes up our air going into the air and fuel mixture going into the ignition point. Okay, so the ignition point and how the air and gas mix through the burner and reach the igniter. Okay, so the igniter in this diagram here would represent the heat. Okay, so the igniter, in which case, would ignite the flame and finalize our complete combustion process. All right, but again, now we're talking 1 cubic foot of oxygen, 12 cubic foot of nitrogen, 1 cubic foot of carbon dioxide, and 2 cubic feet of water vapor. Okay, that make up our air fuel mixture. So now as we take a look back at our combustion chart, or our CO2 to O2 relationship chart, we can see, looking on this line here, that adding the excess air to the equation brings our CO2 and oxygen levels to a more acceptable level. All right, so you're typically, for proper combustion, you're typically going to see that CO2 and oxygen level range between 6 and 8%. Naturally, split 50-50, 7.5 to 7.5 would be, a perfect scenario. But you're going to have some ranges between 6% and 8% based on the CO2 to O2 relationship. All right, but as you can see at this chart, this is bringing in 50% excess air. Okay, so we talked about our rule of thumb at 10 cubic feet per cubic foot of gas. All right, so we then move to adding an additional 5 cubic feet of excess air. Okay, so adding that 5 cubic feet of excess air is 50% of our original 10 cubic foot value. Okay, so that's now referenced as a percentage to the initial 10 cubic foot, or 10 cubic feet, excuse me. So as you can see here, this is essentially an almost perfect combustion on a gas burning appliance. Okay, next on the list is carbon monoxide air-free. And what this is a measurement of how well the fuel and air mix to convert to water or water vapor and carbon dioxide. All right, it's going to show this as a parts per million based on the CO level as if there were no excess air. So if we weren't pumping excess air into the system for the combustion process, this is what your reading is going to show. So in a nutshell, that is how the combustion ticket and the items shown on the combustion ticket are broken down. So you should be able to use these items going forward to know whether or not a furnace or an appliance in the HVAC industry is creating combustion that should be functioning at the proper level. Now, the next little section that we're going to get into is AFUE versus field steady state efficiency. One of the things that I really want to point out here is these are not one and the same. Okay, so you cannot expect, while performing a combustion analysis, you cannot expect a furnace or other gas burning appliance to constantly hit that AFUE rating that the furnace is rated at. All right, we've all seen these big yellow flashy AFUE energy guide stickers on the equipment nowadays. All right, one of the things that we really want to point out going forward, again, this is not the same. Okay, there are a lot of things that factor into steady state efficiency as compared to the AFUE rating. Okay, some of those things are going to be broke down on a list here for you. For a furnace and an HVAC system, things like orientation, the gas rate, the ambient temperature, combustion air temperature, vent restriction, the length of your and diameter of your vent pipe and the termination type, whether or not the pipe is insulated, main power voltage, gas type, whether it be natural gas, propane, fuel oil, temperature rise. Temperature rise is another one that directly impacts the efficiency of the equipment. Are we getting proper airflow through the system? Okay, and that directly correlates to duct static pressure. As we all know, an increase in duct static pressure leads to a fall off in airflow, unless you're specifically dealing with a variable speed blower. All right, some of the other things that impact burner runtime. Like we said before, these pieces of equipment have to reach what we call steady state. Okay, which is typically after about 10 to 15 minutes of runtime. All right, so burner runtime directly impacts. And then also, last but not least, we're talking about, equipment cleanliness. How often is the equipment serviced? All right, because this directly impacts the heat transfer within the system. Most of our equipment is doing heat transfer through, some kind of metal. Okay, and if that metal gets dirty or has any kind of buildup or film, this also directly impacts the equipment and the efficiency of the equipment. And then your analyzer. Okay, your analyzer, again, there are many different manufacturers of analyzers out there, and there are some different things with the analyzers that directly impact the steady state efficiency of the equipment. All right, the analyzer type. How accurate is that analyzer? All right, analyzer calibration. Did the technician let it fully zero in the outside air before using it? Condensation in your sample tube. That can also directly impact your reading. The analyzer probe location, and this results directly back to following the manufacturer's instructions. Are you using the best location in the vent pipe to take this analyzer reading? All right, and then last but not least with that, analyzer maintenance. As we mentioned before, different analyzers could use different types of sensors. Okay, they all have, like some of our high-tech control boards now, they all have built-in software with algorithms programmed in them to, take a simple reading and then be able to configure and pull and convert other readings to add to that combustion error ticket. All right, so as we saw on our CO2 to O2 relationship charts, these readings can be converted based on a specific reading. All right, based on the relationships that the gases have with one another. All right, so therefore analyzer maintenance directly impacts your readings from, in steady state efficiency. All right, now AFUE tests. Okay, these are the tests that the manufacturers perform to rate the equipment. Okay, and I'm sure everyone has heard this before. In a product line for a manufacturer to claim an efficiency level on a piece of equipment, typically they only have to reach that efficiency level or AFU rating with one product in the lineup for them to be able to claim it across the entire lineup. So for instance, if you have a single stage 95% high efficiency gas furnace, all right, if you have this furnace, okay, it may only achieve that 95% AFUE rating in the 120,000 BTU furnace size. But since they achieved it in that furnace size, they are allowed to claim that AFUE rating across the board on the entire line of single stage 95% furnaces, or say model lineup. All right. So, some of the other things to point out, when these tests are performed at the factory, okay, they are guaranteeing the equipment is in a steady state process. All right. You have cool down applications, tracer gas, all right, heat up applications, and cyclic condensation collection. So they can take condensate samples and test the condensate samples to see exactly how that furnace is performing. All right. So test configurations and conditions are specifically specified in their testing applications. All right. They're not dealing with things that we deal in the field, like, different types of plenums, static pressure control. Okay. Static pressure control, when you install a furnace into an application that may not be quite up to par on the ductwork size, all right, which increases your static pressure, all right, directly impacting the amount of airflow through that system. Okay, the manufacturer has static pressure control gates, all right, so they use vent dampers and things of that matter to where they can pinpoint a static pressure level to get their airflow perfect through the system when they're doing their testing. All right, and then the other thing is thermocouple locations. So when you're taking temperature readings, all right, are you taking the temperature reading directly above the equipment in the plenum? Are you taking, your temperature reading up and around the corner in the trunk line, or if there's multiple trunk lines? Okay, are you taking your temperature readings in each trunk line and then averaging them? Because this all directly impacts the performance of the furnace or fuel burning equipment. Okay, taking a temperature reading in a plenum directly above a piece of equipment allows radiation heat to affect your temperature reading. Radiation heat directly off of the heat exchanger will affect your temperature reading when you're taking a temperature in the plenum. All right, so again, these test conditions are specified in the AFUE testing. Okay, they know from their energy provider, they know the exact BTU input in the gas. Okay, They know the exact ambient temperature that they're measuring in. And humidity, the humidity is pinpointed. All right? The rates, the temperature rise, the static pressure, the voltage, it is all set and specified specifically for their application. All right, so in other words, they are testing in perfect conditions compared to what you're going to be testing against in the field. Furnace orientation is another aspect that directly impacts efficiency. Um, if you have a furnace being installed in a horizontal application, whether it be horizontal left, horizontal right, downflow, these also directly impact a steady state efficiency reading. Okay, a furnace might not perform, the way that it should the way that it does in an upflow position as it would in a horizontal left or a horizontal right or even a downflow position, because there are changes in the application that directly impact those readings and efficiencies. All right. So, but here going forward, we're gonna jump into some of the enhancements on the post FER 90% gas furnaces. All right, we're going to talk about some changes that were made to the furnaces. I'm sure by now everybody's aware of the FER rule or fan efficiency rule that took place back in July of 2019. This ultimately dictated some changes, specifically with the blowers in furnaces going forward. So they have to now meet a certain efficiency level on the electrical side in the equipment now, which directly impacted blower motors and the furnaces. Okay, so as we dig into the equipment side of things, we're going to talk about how the equipment and introduction of new equipment is now currently available after the FER rating has changed. All right, so the first thing you're going to notice is the addition of a two-stage fully communicating unit to the product lineup. All right, as I'm sure you've all recognized by now, we have had some nomenclature change in the gas furnace lineup that's a little more detailed given the features and capabilities of the equipment. These have now been added into an extended model number nomenclature. All right, so now on top of a high efficiency two-stage unit, we now have the addition of a two-stage unit with a communicating blower, which allows full functionality with a communicating thermostat like the ion control. The ion control, as I'm sure you're all aware, is the latest and greatest communicating thermostat to come from the ICP line of products. All right, so be on the lookout for an additional training video where we're going to break down these furnaces and break down specifically the motors that have changed in these furnaces. We're also going to put together a training video to specifically break these motors and motor types apart and explain the differences, troubleshooting processes, and things of that nature from these different furnace products. All right, that specific training will be labeled as Motor City. Okay, so be on the lookout for that going forward. Some of the other things that we've seen, going to the different model lines in the blowers is the type of signal that the motors receive. All right, so we're going to break down into three different. Initially, there was four different types before the FER rule came into play. As we all know, at this point, PSC motors have been since phased out. They were phased completely out of manufacturing as of July 2019. All right, we do still have some of these furnaces floating around within the company. Okay, so these furnaces are allowed to be sold as long as there's no manufacturing date posting after July of 2019. So you can still get the occasional PSC furnace that's sitting around in a warehouse somewhere that was manufactured prior to July 2019. Okay, there are a very limited there is very limited availability on those furnaces, however. All right, but the three types of motors that we're going to talk about is the what we call the VCA, or variable constant airflow. All right, that furnace, or that model blower, is going to be a fully communicating motor. Okay, and what that means is, from a communicating aspect, that allows the motor to communicate back to the control board of the furnace its RPMs. Okay, and what this does, as it communicates the RPMs back to the motor, this is in turn referencing the static pressure that the system is working against. So as it communicates those RPMs back to the control board converts that into the pressure that the blower is working against, and therefore can ramp the motor up and down based on that pressure variance. Okay, and then the next one we're going to talk about is a variable speed constant torque motor. Okay, and as you can see here on this chart, that variable speed constant torque motor is the motor that used to be used in the G9 or F9 MVE series two-stage gas furnace. All right, so what the variable speed constant torque does for the motor, it allows it to have that variable speed capability. However, there is no communicating feedback from the motor, which means the control board cannot ramp the motor up and down based on the resistance that the motor is working against. Okay, so in cases where you have specifically a slightly restricted air filter or a slightly restricted evaporator coil, your variable constant torque motor is not going to overcome that added resistance. That signal is, or the signal to the motor is a pre-programmed speed signal sent from the control board to the motor, and that signal stays constant based on what mode or what have you is the system is in, and the pre-programmed algorithms in the control board. All right, so essentially it acts very similar to an X13 motor. However, you have many more speeds and a larger speed range capability with that variable speed constant torque motor than you would, say, an X13 motor. Okay, and then the next one on the list is what we're going to call a fixed constant torque motor. Okay, so this now is the replacement for the X13 motor, or takes place of the X13 motor. All right, and previously you saw those in the G9 MXT models or F9 MXT models, and the G9 MXE or F9 MXE models. Okay, real quick, let me revert back to the G9 MVE with the variable constant torque motor. That motor you are going to now see in the G96 VTN, Victor Tango November. Okay, so that is the new nomenclature for that specific furnace. All right, and now back to our X13 motor. Okay, X13 essentially was a brand when it was initiated and initially manufactured. Okay, X13 kind of became the standard default name for that fixed constant torque motor. All right, but the true name for that motor is a fixed constant torque or constant torque motor. Okay, so that X13 motor is going to have the essentially the same capabilities as the variable constant torque. It's just not going to have as much of a speed range and as many speeds associated with the motor. Typically that motor has a 5-speed tap selection connection on the motor. All right, so you're going to be limited to 5 speeds on this motor. All right, still has the same efficiency as the variable constant torque and the variable constant airflow motor, but you're going to be limited to 5 pre-programmed speeds in the motor. All right, so there have been enhancements to the mainline series as well as the entry-level series. As you can see on the middle chart on the right-hand side, your standard ECM or fixed constant torque motor is now the base product of the furnaces. Okay, it's going to be just a single stage furnace with a fixed constant torque or standard ECM motor. All right, and the efficiency on those starts at 92%, as referenced in the N92ESN model number and the N95ESN model number. All right, there is also a Meritherm series of this product that starts with R. Okay, R references the beginning of the model number as a Meritherm product. Typically the only difference between these is paint color of the cabinet, and that's pretty much about it. Otherwise features the same efficiencies, same features as the entry-level Comfort Maker or Tempstar series. All right, so we've added 14 new SKUs, or essentially 14 new furnaces to the furnace lineup as of the FER rule, and as you can see, they are added throughout the tiers of the lineup. Now let's talk about the ion control for just a minute here. All right, the ion control is the latest and greatest communicating control from ICP. However, this control is not compatible with every furnace. Okay, this control has to be used with a furnace that has a communicating blower to take advantage of all the features available between the equipment and the controller. All right, beautiful looking thermostat. Some of the things that have changed is that you now have, or the homeowner now has full control over the airflow of the system, specifically in the constant fan on mode. They now have speed selections. All right, so typically, in the past, specifically with PSC furnaces and even fixed constant torque furnaces, they only had one speed selection, which was typically high speed with the fan on position. Okay, but now with the addition of new control boards and communicating controls, they now have options of different speeds for the constant fan on position. All right, so the chart on the right shows the compatibility of furnaces with the ion control. As you can see, everything that's over there marked in green is full feature set with the ion control, all of which contain a communicating motor in the furnace. All right, I am going to forewarn you, the G96 VTN Victor Tango November is not compatible with the ion control. Even though this chart says that it has limited functionality, it is not compatible. You will end up with airflow issues. So just to kind of fix the correction on this chart, it is not compatible. The ion control is not compatible with the G96 VTN Victor Tango November. All right, as you can see in the fan coils, you have to have a full communicating, which is the FCM, Foxtrot Charlie Mike, model air handler. All right, so like I said before, there have been many enhancements to the furnaces, to the furnace lineup since the FER rule has come into place. All right, we're going to go through each of those quickly, um, to try to show you the differences between the changes of the old furnace models and the new ones. First thing we'll start out with is control boards. All right, control boards by now, guys, at this point you should know control boards, there are no universal replacements. Most control boards now are in the furnaces, specifically after the FER rule came into place. They're proprietary to each furnace. All right, so there is no off-the-shelf universal solution or replacement for these furnaces. They have to be OEM replacements. All right. Quality control from the ground all the way through production. All right, the control boards are no longer being designed by control companies, companies that you guys I'm sure were familiar with in the past, like Texas Instruments. Let's see, UTC. UTC was a big one in control board manufacturing. Okay, these a lot of these control boards now in the furnaces are built from the ground up, designed by the manufacturing engineers, and built from the ground up by the manufacturer. All right, so that all includes the fault detection, also with the programming for the ECM motors, blower speeds, airflow ranges, all of that are done by the manufacturer nowadays. Another addition to the product lineup is extended wire harnesses. All right, we've got extended wire harness lengths that allow you to remove the blower assembly without having to disconnect the control boards, which is a feature I'm sure all of us service technicians have been asking for many, many, many years. All right, because in the past it's always been a real pain in the rear to have to completely disconnect a control board from a blower assembly to pull the blower assembly and replace a motor or a blower wheel. All right, this also ultimately makes it easier to troubleshoot with all the connections intact. All right, also pairs well with the full length blower assembly rails. All right, that with the front facing screws that allow the blower housing to be removed much easier. Gas valves. All right, so at this point, most of your installers or service technicians are aware that the pressure ports on the gas valves have been raised to make for an easier connection. Makes adjustments easier on the gas valve. Makes it much easier to check inlet and outlet gas pressure. All right, the modulating gas valve is just another example of the proven leadership and technology in the equipment. All right, modulates up and down during the same cycle, all right, like nobody else out there has. Hose clamps, I'm sure you've all seen the arms have been lengthened on the hose clamps for the drainage. These guys typically come in your little parts bag. Just a little pun here. It's a good squeeze play on old technology. All right, I'm sure many of you have had the experience of one of these guys slipping out of your pliers and going flying across the room, and then you are trying to track it down. The condensate traps. The condensate traps now have a translucent front. All right, this allows the technician to see if there are any kind of residual or products in the drainage system that could potentially pose a threat of clogging the drain. All right, makes for a much easier to maintain system. All right, allows you to check the drainage without removing the entire trap. Another feature that's been added is the fixation of the dip switch settings. Specifically on the two-stage VTN furnace or variable constant torque, these dip switch settings have to be set to configure your airflow settings based on your application. All right, so these dip switch settings are now affixed to the furnace doors for much easier access. That way we don't have to break into the installation manual to track them down. This then creates a much faster installation process. All right, rotating elbow. This was in our previous furnace lineup. However, there have been some slight enhancements to it going into the FER furnace lineup. All right, allows you to reconfigure the venting or exhausting of the furnace through different sides of the furnace based on the furnace installation orientation. All right, so you can vent the furnace through the top and either side of the furnace. All right, again, ultimately resulting in faster installations. The door switch has been upgraded to a rounded edge switch, all right, which helps keeps the doors on in a straight position and allows for 100% true and tight fit. Top panel, insulation on the top panel has been modified to create a more flush fit for the evaporator coil. Also allows for easier top entry of gas and electrical. Enhances perceived quality of installation, and ultimately resulting in faster installation. All right, on the 5-ton variable constant torque model furnaces, so this would be the G96 VTN or the F96 GTN, whether you're Comfort Maker dealer or Tempstar dealer. The addition of a power choke to this furnace allows the unit to still use a 15 amp electrical service. All right, the blowers on these furnaces are much larger, being that they have a 5-ton drive, require a higher amp draw. The power choke allows that amp draw to come down within the limits to still have a 15 amp rating on these 5-ton drive furnaces. So keep that in mind. All right, doesn't require the heavier gauge wire for a 20 amp circuit from a 15 amp circuit. All right, again, ultimately resulting in faster installation if you don't have to replace an entire circuit to a furnace. All right, so just to kind of point out a heat exchanger milestone, the same heat exchanger has been brought forward into the new FER furnaces that came from the last model series. All right, it was introduced 6 years ago and has achieved over 500,000 cycles on the life cycle test at the factory. All right, which is equivalent to over 50 years of use. And this heat exchanger that is in the testing chamber is currently still going strong with no failures. So this same design is now used in the post FER or after FER furnace lineup. The doorknobs on the furnaces have been improved with some movement adjustments for better sealing of the doors. Saves time by not requiring any tools to access the furnace. All right, simplified accessory kit literature. Accessory kits to the furnaces will now come with a more detailed, easy to follow instruction manual. So a huge benefit there. All right, and then the next thing we're going to talk about is the enhancements to the 80% furnaces. All right, so very similar to the 90% furnaces, you're going to see models with the variable constant airflow motor, multi-staging capability. All right, we're also still going to have models available with the variable constant torque motor, and the standard 80% now contains a fixed constant torque motor, or standard ECM, if you will. All right, so just to kind of reference some of the old models compared to the new models, the G8 MVL, which was the premium mainline two-stage 80% furnace, has now become the G80 CTL, which is communicating two-stage low NOx furnace, contains the variable communicating constant airflow motor. All right, has multi-cooling stage capability. Okay, and then in your performance or entry level, what we call entry level product, your N8 MXL was a single stage furnace with a fixed constant torque motor, is now the N80 VSL, which is a single stage furnace with a variable constant torque motor, but has the capability of multi-stage cooling. All right, and that's going to contain the variable constant torque motor. Okay, and then your entry level single stage product, which will not have the multiple stage cooling application capability, is going to be your N80 ESN. Okay, so, and then you also have a Meritherm version that starts with R, which is the same essentially, except for basically the color of the cabinet. All right, there's also been some warranty enhancements to the 80% furnaces as well. All right, some of the newer models, some of the newer models actually have newer size and tonnage ratings to help eliminate oversizing of heating. So on the 13 and 16 SEER products, you can still attain your airflow on, on a 5-ton unit. You now have a 90,000 BTU furnace with a 5-ton drive, allowing the limitation of oversizing the furnaces. All right, in the 4-ton model, you have the addition of a 70,000 BTU furnace with a 4-ton drive, and in the 3.5-ton drive, you can get in up to a 70,000. We've also got some improved high static cooling capabilities. Typically what we would like to see in specifically the horizontal position, that's typically where we run into a lot of high static applications. Making the furnace cabinet wider typically will alleviate a lot of those static pressure issues. So your limitations through the furnace itself or through the furnace and coil can typically create a higher static application. So now allowing the larger blowers with the smaller BTU ratings of the furnace allow for some of that static pressure to free up. As I said, there have been some improvements to the heat exchanger warranties, or to the warranties on the mainline 80% furnace. They now come with a lifetime heat exchanger warranty as compared to the existing or pre-existing 20-year warranty to the old products. All right. Now, if the equipment is not registered, it still defaults to the 20-year. But if that mainline 80% unit is registered, it now obtains a lifetime warranty. All right, and again, the model nomenclature on the furnaces have changed, adding more descriptive model nomenclature to describe the features available in the equipment. And that wraps up our training for today. I hope this was of great value to everyone that attended. Should you have any questions, please feel free to reach out. I will do my best to respond in a very timely manner. Otherwise, be on the lookout for additional virtual training videos that we'll have coming your way shortly. Thank you and have a good day.